alloying. The first step of the process followed in this plant is alloying. It is the foundation for preparing the desired magnetic properties of the final product. It involves melting and homogenizing raw materials into an alloy. The raw materials are charged into a vacuum induction furnace in vacuum conditions and melted by electromagnetic induction. The melt is held at a controlled temperature up to 1,500 degrees Celsius to ensure proper alloying and homogeneity of elements. The second step is strip casting. This rapidly solidifies the molten alloy into thin flakes by directing a sheet of molten alloy onto the surface of a water-cooled copper roll, forming the desired microstructure. The molten neodymium iron-boron alloy is poured from the crucible into a tundish. The molten alloy exits the tundish and contacts the surface of rotating copper wheel. On contact, the molten alloy is instantly quenched and solidifies into thin flakes. Cooling rates exceed 100,000 to 1 million Kelvin per second, refining the microstructure and minimizing segregation. Hydrogen decrepitation. The third step is critical for preparing feedstock powder for sintered magnet production. The purpose is to break down, to decrepitate, the strip-cast neodymium iron-boron alloy flakes into fine, friable powder using hydrogen gas. This makes them suitable for jet milling and later pressing in sintered magnet production. The strip-cast flakes absorb hydrogen gas to form two different hydride phases. The different volume expansions of the two phases result in cracking and embrittlement of the alloy microstructure. From this point onwards until the magnet block coming out of the sintering furnace, the material does not come in contact with oxygen. Everything takes place in vacuum.